All right, this is the biggest section from chapter 773 on similar triangles. The first two slides need to go into your notebook. These just explain what the theorems are that we're going to be using for shortcuts for these proofs. These are not the proofs like the old chapter. These are, all you have to do is kind of just show your work a little bit. You don't have to write out like statements and reasons, and you'll see when I do these. The next two slides are going to be short. I'm not going to talk. You're just going to have to pause it to copy them down. So this first slide is the similar triangle shortcut theorems for AA similarity and SSS similarity. And this slide is the similar triangle shortcut theorem for SAS similarity. And remember, similar figures have the same shape and different sizes. And so we're trying to figure out using these three, AA, SSS, and SAS similarity, if the figures are the same shape but different sizes. So we've got 7 examples. You can copy down the examples or not. They're going to go pretty quick. First example is AA example. All the directions will be the same. Are the two triangles similar? And why? Write a similarity statement if they are similar. So here we have two triangles with parallel lines. That means you're going to be using like corresponding angles, alternate interior angles, or something like that, because when you see parallel lines, that's what you should think. We've talked about this for a very long time. I know it's been a while since we touched on it, but here it is again. The answer is yes by AA similarity. The reason why is we know that two sets of angles are congruent. RSX and TSW are vertical angles, so they're congruent. That's one set of congruent angles. And R and W are alternate interior angles because they are on opposite sides of the transversal, which is RW, and they're alternate sides of that transversal as well. So we have two sets of angles that are equal, therefore the triangles are similar, and there's my similarity statement. Remember, when you write the similarity statement, the angles have to match up, so since R was congruent to W, they go in the first place. Angle S was congruent to angle S if you just use the middle letter, so it has to go in the middle, and then X and T are the leftovers. It's very important that you get those letters in the correct order when you write similarity statements. That's more or less the hardest of the angle-angle similarities. Here's a little one that's a little bit easier. Same directions. So the answer for this one is also yes, yes, because of angle similarity. Now you might say, Mr. Schneider, I don't see two sets of equal angles. We have a 48 and a 57, and the other one's a 57 and a 75. There aren't two sets that are equal. 57 and 57 are equal, but 48 and 75 aren't. We'll figure out your third angle. You can figure out the third angle of the large triangle, which is angle Q, by subtracting 57 and 75 from 180, because all the angles of a triangle add up to 180. So 180 minus 75 minus 57 is 48. Therefore, Q is 48 degrees. Therefore, J and Q are congruent to each other. So L and M are congruent. They're both 57. J and Q are both congruent. They're 48. Therefore, they are similar by AA because we have two congruent angles, two sets of congruent angles. This time I can match them up by using the numbered angles. J is 48 and Q is 48, so they go in the first position. L is 57 and M is 57, so they go in the second positions. And then K and P have to go in the last positions because they're the leftover angles. Here's another AA example. This is one that doesn't work. Okay, so here we have same idea where we know two of the angles and not the third one. And you might say, hey, Mr. Snow, you just showed us it can work out. But this time it doesn't work out because if we figure out what angle A is, again, all the angles of a triangle add up to 180. So 180 minus 90 minus 44 is 46 degrees. Angle A is 46 degrees. So C and D match because they're both 90, but nothing matches the 47. And if you actually worked out G, you would get 43. So you'd have a 44, a 46, a 47, and a 43. None of those match. So since you only have one set, it is not a similar triangle. That's pretty much all you have to do is just explain things. Sometimes you don't have enough information. Sometimes you can prove that it's not true. You'll see one later that we just don't have enough information as well. All right, these are the SSS examples. So we are looking for three sets of proportional sides. If the sides are all proportional, that means the triangle either grew or shrunk at the same rate for all three sets of sides, and therefore the size is the same. The shape is the same, but the size is different. So you set up three proportions and then cross multiply. So what I'm going to do is I'm going to put on these three proportions that you can see here, I'm going to put my small triangle all on the top and order those from least to greatest. So I've got 5 on top is the smallest side of the small triangle, then 6 is the medium size side of the small triangle, and 8 is the largest side of the small triangle. Then I put the large triangle in ascending order across the bottom. 12.5 is the smallest side, 15 is medium, 20 is large. Then you cross multiply and see if the products are equal. So you do the first two and see if those two are equal. Then you do the last two and see if those two are equal. You don't have to do the first and the last. So if we do the first two, you get top left times bottom right. 5 times 15 is 75. Bottom left times top right. 12.5 times 6 is 75. Those are both 75, so it works out. Then check the next set. 6 times 20 is 120. And then the bottom left times the top right. 15 times 8 is 120. Therefore, the products are equal. Since all of the products are equal, that means the sides are proportional. And because the cross products are equal, the sides are similar by SSS similarity. So I go around in ascending order. So R, Q, P, because R to Q is the smallest side, Q to P is the medium side, and then it goes back to R. R, Q, P. And then for the larger triangle, the similar sign is that little tilde. Start at R, go down the smallest side, which is 12.5 RT, then down the next biggest side is S and back. So that's one that works. Here's one that doesn't work. Same idea. Set up the three proportions, then cross multiply. The small triangle, smallest side is 4. The medium side is 5. And the large side is 8, so those go across the top. Then on the bottom of the fraction, you put the large triangles. So the smallest side from the large triangle is 6. The medium side is 8. And the large side is 12. Then you do the cross products to see if they're equal. Because if the cross products are equal, then the sides are proportional. So I did 4 times 8, top left times the bottom right. 4 times 8 is 32. Then I did the bottom left times the top right. 6 times 5 is 30. 32 and 30 are not equal, therefore they're not similar. We don't even have to check the other ones. If one set is not equal, then none of them are proportional. And so therefore they're not similar. So because my reasoning is down there, because the cross products are not equal, the sides are not proportional, and the triangles are not similar. Finally, the toughest one, side angle side example. These are ones where you have to have one included angle set equal to each other, and then also one set of sides that when the cross products are equal, or when you multiply the cross products, they're equal. And since the cross products are equal, the sides are proportional. So you have to do both. Find the included angles that are equal and also find proportional sides. Now again, for SAS problems, first you have to check and see if the congruent angles are included. Included means it's between two known sides. So if I look at angle A's adjacent sides are known sides, 3 and 4. We know that AB is 3. We know that AC is 4. F is not included because DF is 6. It's a known side. However, the other side, FE, that's adjacent to F, is unknown. So that means that it can't be an included angle. And since the angles aren't included, there's not enough information to know if the triangles are congruent or not. They might be, they might not be, but we just don't have enough information. Final example. All right, so this one is the hardest one probably of the SAS. This one, you're comparing the triangle AEF at the top, which is inset inside of the large triangle ACB. So that bottom part with the 4 and the 5, the 4 and the 5 aren't part of a triangle. They're part of the trapezoid at the bottom. Okay, so angle A is included for both triangles. It's the angle at the top. It's AE and AF are known sides, 8 and 10. And then for the large triangle, AC is known side, it's 12 because 8 plus 4 is 12, so that whole side is 12. And then AB, 10 plus 5 is 15, so AB is 15. All right. So again, I'm adding those sides to get the whole length of the side down the side. 8 plus 4 is 12 for the whole length of AC, and 10 plus 5 is 15 for the whole length of AB. A is congruent to itself because of reflexive property, so then you set up a proportion to see if the sides are proportional or not. So AE is the small side of the small triangle. over AC, which is the small side of the large triangle, which is 12, 8 over 12. And then AF is the small side of the large side of the small triangle, divided by AB, which is the large side of the large triangle. Cross multiply to see if their cross products are equal. If they're equal, then it's proportional. And if it's proportional, then we have SAS similarity. Top left times bottom right, 8 times 15 is 120. Bottom left times top right, 12 times 10 is 120. The cross products are equal. And because the cross products are equal and the included angles are congruent, we know it's proportional and the triangles are similar by SAS similarity. And then I wrote there AEF is similar to ACB. So after you get done watching this video, work on the 7.3 worksheet that either I provided you or the sub provided you, depending on which group you are. And if you have any questions, email me. If you have any questions, like work together. I know you can't like move seats, but like you can talk. Like let the sub listen to this part of the video and be like, hey, he said we can talk, because I want you to be able to work on this and not just waste your time in class because you can't figure out, or maybe you think you know it, but you need to talk to somebody. It's okay to talk during this section. We'll go over it a little bit when I get back next Tuesday. And that's kind of it. So hopefully this helped you understand a little bit more. If you didn't watch the 7.2 video, then this is going to be like your first go around. It might be a little bit harder to understand. So 7.2 video also needs to go in your notes, just like the beginning of the 7.3 video. If you have any questions over the weekend, shoot me an email. I'll be back to school, like I said, next Tuesday. Bowling season's almost over, so hopefully I'll see you then. Take care, and good luck with your work.